Hi everybody, Mrs. Wild here. I hope you're okay and you are enjoying our fraction journey. We are on day 3 of our fractions. And for today's lesson, you are going to need your week 5 booklet. And we're looking at here, equivalent fractions part 2, lesson 3. So I'll go on to here. Let me find it. Oh, there we go. On there, up in the top corner, it says the 3rd of the 2nd, 2021. So you need that bit. And you're also going to need Power Maths Book B, pages 80 and 81. So Book B, you're also going to need that one. So make sure you've got those things before you start. And you're also going to need, if you've got them, your fraction tiles that you made at the beginning of the week. If you haven't made fraction tiles, they're really, really good to help you when we're doing a lot of things. So make sure you watch the video from Monday. That will help you to make them. So I'm going to share my screen to start with. So today we are continuing to look at equivalent fractions. So we're going to look at the fraction tiles and order these fractions from smallest to biggest. So you're going to need your fraction tiles and you're going to look at those fractions. You're going to order them from smallest to biggest. So we've got a half, a quarter, a 12th and an 8th. And we're going to decide which is the biggest fraction and which is the smallest fraction. So we're going to start with the smallest and we're going to work to the biggest. So I'm going to write them on a whiteboard to help me remember. I'm going to stop my screen share. I'm going to show my different camera. Hopefully you're going to see these now. Come on. There we go. Right, so they're the fractions and we're looking at them. So I'm going to use my fraction tiles that are here. So I've got a half. Let me find my half fraction tile. It is. I'm going to fold it so I can just see one. So that's 1/2. Got 1/4. 1/4. What's the other one? 1/12. Oh, 1/12 is tiny. If it'll let me fold them all up. Oh, 1/12. Oh, look, it's all smooth now. And 1/8. There's my 8. So we're looking at these now to help us decide which is the biggest fraction to the smallest fraction. Oh no, smallest to the biggest it said, didn't it? So let me have a look. Well, it's really easy to see here that my 12th is the smallest fraction. So I'm going to do 1/12 is the smallest because I can see that it is the smallest amount of my whole. 1/12 is the smallest. Then which is next? Have a look. 1/8, correct. 1/8. And then 1/4, good. And then finally, 1/2. Now you might be thinking, but Mrs. Wild, this denominator is 12, that must be bigger. No, the bigger the denominator, when the numerator is 1, the bigger the denominator, the smaller the fraction, when the numerator is 1. So when the numerator is 1, the bigger the denominator, the smaller the fraction. Okay, I hope that makes some sort of sense, guys. Right, let's go back to screen sharing. Okay, so we're going to look at the first one. So here we've got shade half of the bar modelling. Half of the bar modelling. Okay, so let's do that first. I'm going to get my highlighter. You can get a crayon. You can just have a normal pencil. It's up to you. And it says shade half of the bar modelling. So I've already got my fraction here. Look, tells me this is 1/2 of the bar model. I'll shade that in. Doesn't have to be perfect. Perfect, just like that. Well done. And then this one says shade 2/4 of the bar model. Okay, well, I can see this has been split up into 1, 2, 3, 4. And remember, we talked about our denominator is what it's split into, and our numerator is how many you want. So I want 2 of these things we call quarters. Perfect. Okay, then this bottom one, it said shade in 3/6 of this bar model. Well, I can see, look, the denominator is 6. 1, 2, 3, 4, 5, 6 equal parts. And we want 3 of these things we call 6. Let me highlight them. Oh. And then it says here, what do you notice? What do you notice? Well, I'm sure you're noticing the same, that they're all equal. They are the same. They're equivalent fractions. They are equivalent fractions. I'm writing this on my laptop. Equal. They are all equal. They are showing the same amount. And then it says, write another fraction that is equivalent. Well, do you remember the rule we spoke about yesterday? That as long as your numerator is half of your denominator, then the fraction is equal to a half. So I could say, I could put 8 on the bottom here. I'd have to half that for my numerator, and that 4/8 is equal to a half. I could do a different one. I could do the denominator of 200. And as long as I halved my denominator to make my numerator 100, so 100 200ths would be the same as 1/2. I wonder how many halves, equivalent fractions to a half, you can come up with. Pause the video and you can write them down. Okay, so we've now got this one. It says shading 2/3 of each bar model. 2/3 of each bar model. So let's have a look. Well, it's nicely here. I can see they've put on here where my 2/3 is. Okay, so 2/3 of this bar model. So even though this bar model is split into 6 equal pieces, I could still work out 2/3 to put it on the bottom for me. So I'm going to do 2/3 of each bar model. And then hopefully this is going to help me to find some equivalent fractions of 2/3. Oh, move that up to the top. It's in my way now, is that? It's in my way. Let me move that. There we go. It says it here. Now, so I've shaded in 2/3 of each bar model. That's what it asked me to do. I hope you've done the same. And then it says, use your answers to parts A, B, and C to complete the equivalent fractions. So the equivalent fractions are up here. You see it? They're up there. So it says 2/3 is the same as so many 6. Well, look, 1, 2, 3, 4, 5, 6. So that's showing me 6s. And I can see it's got 1, 2, 3, 4 of them. So 2/3 is the same as 4/6. Which is also the same as so many of 8 something. So let's have a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The denominator for that one is 12. So it's also the same as 8/12. But this one is quite interesting. Look, this one here says so many 15s, and we haven't got a bar model split up into 15s. So this is what I'm going to do. I'm going to look at the relationship between 3 and 15. What do you do to 3 to get to 15? So what do you do to 3? I times it by something to get me to 15. So 3 times what makes 15? Shout it out. 5. Good. So I know I've times my denominator by 5 to get me to the 15. So I must do exactly the same to the numerator. So whatever you do to your denominator, you do to your numerator. So I must also times that by 5. 2 times 5 is 10. So 2/3 is also the same as 10/15. I hope you're understanding this, guys. You're doing a great job. I'm very proud of you. So there we go, look. Here's the way for finding equivalent fractions. So what do we notice? 2 to 4, 3 to 6, 2 to 8. 1 to 2, 1 to 2, 1 to 4. So let's have a look. 2 times what equals 4? Times by 2. And remember, whatever we do to the bottom, we must do to the top. So look, 2 times 4, 2 times 2 is 4, 1 times 2 is 2. What's happening here? 3 times what is 6? 3 times 2. Good. And whatever we do to the bottom, we must do to the top. 1 times 2 is 2. 3 times 2 is 6. So this shows us equivalent fractions, guys, because whatever we're doing to the bottom, we're doing to the top. So it's just creating us an equivalent fraction. 2 times what is 8? 2 times 4. Good. And then 1 times, we have to do the same at the top, 4 is 4. So let's put this into practice now. Oh, look, there you go. There was your answers. We just did that together. So let's put it into practice. So we've got 5 here and nothing here. And we've got a half here. So whatever we do to the numerator, we must do to the denominator. So let's figure out 1 and 5. What have we done to number 1 to get to 5? We have times it by 5. So we must do the same to the denominator. 2 times 5 is 10. So 1/2 is the same as 5/10. And look, you can see that here. 1/2 is here. And then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got tenths at the bottom. And 5 of them are shaded. So I can see that 1/2 is the same as 5/10. So I can check my answer as well. So now let's look at these. Pause the video and you can have a go at doing these by yourself and then come back and check your answers. So pause it now. Okay, welcome back. So whatever we do to the numerator, we must do to the denominator and vice versa. So 3 times something is 3. 1 times something is 3. Correct. 1 times 3. So we must times the bottom number by 3. So 2 times 3 is 6. Perfect. So now let's have a look. We've got 1 and we've got 10. What have you done to 1 to get to 10? You have times it by 10. Brilliant. So we must times the bottom number by 10. 2 times 10 is 20. So 1/2 is the same or equivalent to 10/20. 1 to 6. How have we done there? We've times by 6. So we must times the bottom one by 6. 2 times 6 is 12. So 1/2 is also equal to 6/12. I hope you're understanding this, guys. You're doing a really good job. We are making equivalent fractions. So now we can look at here. We've got some missing numbers on here. We've got, you can see 2 14s, 4 14s, something 14s, 8 14s. And on the bottom, we've got 7. So we're looking at making equivalent fractions. Well, I can see that these are going up in ones. So I've got 1/7. Well, they're going up in sevenths, sorry. So I've got 1/7, I've got 2/7. I've got 3/7, 4/7, 5/7, 6/7, and 7/7. So now I've got to fill in the top. So let's have a look at the relationship between them. Well, I can already see that all these are 14. So whatever I do, I'm going to be having a 14 here. And I'm going to be having a 14 here. And I'm going to look at my relationship. So I can see what has happened here. So what has happened to 7 to get to 14? We have times it by 2. So whatever I do to my denominator, I do to my numerator. 3 times 2 is 6. So I know it's 6/14. So again here, look. What have I done to 7 to get to 14? I've times it by 2. So I must do the same with my numerator. 5 times 2 is 10. So 5/7 is the same as 10/14. So then here again, 7 to 14, I've times by 2. So I must again times 6 by 2, which would give me the answer 12. 12/14 is equal to 6/7. So let's have a look down here. We've got fifths along the bottom and 15ths along the top. What have we done to 5 to make 15? So to fifths to 15ths, we have times it by 3. So we must now do the same with our numerator. 2 times 3 is 6. So 2/5 is the same as 6/15. Let's look at this one. So I've already seen here that I've got my 3 numerator and my 9 numerator. And for 3 to 9, we have times by 3. So I must do the same to my denominator. My denominator, 5 times 3 is 15. So 3/5 is equal to 9/15. Let's have a go at this one. 5 to 15 again, times by 3. So then 4 times 3 is 12. So 4/5 is equal to 12/15. Now, we know this one's going to be 15ths because that's what it is on the top. So we do 5 times 3 to get the 15. 6 times 3 is 18. Well done. Now, don't freak out. I know the numerator is greater than the denominator. We're going to be looking at that next time and looking at what it means when the numerator is greater than the denominator. So don't worry about that one. It is okay to have that. Right, and now I want you to go into your Power Maths books, and we're looking at pages 80 and 81. So I'm going to stop my screen share. I'm going to open up my Power Maths book at page 80 and 81. 80 and 81. Perfect. Here we are. So we are on equivalent fractions 2. Let me up a little bit. There we go. Equivalent fractions 2. This is where I was just going to get her pencil that seems to vanish every time she comes to need it. So she'll use another pencil. Oh, I found it. It's here. There we go. So pause the video and have a go at solving page 80 and page 81. And then come back and I'll show you the answers. Okay, welcome back. So use the shapes to find equivalent fractions. So I can see here, this is 2, we have it split into 2, so my denominator must be 2, and only one part is shaped, so it's 1/2. And here, it's been split into 6 equal parts, so my denominator is 6, and 3 are shaded. Okay? Here, 1, 2, 3, 4, 5. My denominator is fifths, and 4 have been shaded, so I've got 4/5 there. So now I need to know what that is equal to, and I can just use this to help me. I could have done this, guys. 5 to 10 is times it by 2, and I could have times that by 2, and that would have given me 8. So I'd have known to colour in 8. And I could have also looked at the symmetricalness, the equalness between these two pictures. Okay, right, let's look at the next one. So 1/4, which is shaded there, is the same as so many somethings. So how many have we got here? 1, 2, 3, 4, 5, 6, 7, 8. So I know my denominator is 8. What have I done? From 4 to get to 8, I've times by 2. So I must do 1 times 2, and that equals 2. So I need 2 of them. I could have also used my eyes and looked to see and make those equal. Obviously, you can colour these in much better than I can. Now, this one's interesting. 10/15 is the same as something. So if I got a ruler, I could turn this into whatever I wanted, but I'm just going to make this really simple. And I'm just going to draw these lines to make those match. And I'm going to colour in the same amount that's on it. And I have made 1, 2, 3 equal parts. So my new denominator is now 3. Now what I could do, say what do I do to 15 to get to 3? Well, I divide by 5. So what do I do from 10 to get to 3? I've got to do the same thing, haven't I? 10 divided by 5. 10 divided by 5 is 2. And there's 2/3. So 10/15 is equal to 2/3. Okay? Let's have a look at the next page. There we go. Perfect. Find the missing numbers. So we've got 1/2 and something 8. Now we've done this, guys. So look at the relationship. What do you do to 2 to get to 8? You times by 4. So you must also times this by 4. 1 times 4 is 4. B. Oh, what have you done to 3 to get to 15? You've times by 5. So you must do 4 times 5, which will give you 20. What have you done to 3 to get to 9? You've times by 3. So I must also times 5 by 3, which will give me 15. What have I done from 6 to get to 24? I've times by 4. Yes, I have. That took me a while. So I must times that by 4. 1 times 4 is 4. 1/6 is the same as 4/24. 7 to get to 21. I've times by 3. So I've then, this is interesting. So I know I've had to times by 3 to get to 21, but if I look at here, I'm wanting to work backwards. So I'm going to say, to get from 21 to 7, I've divided by 3. So I must do 6 divided by 3, because I'm inverting it. 6 divided by 3 is 2. 2/7 is equal to 6/21. Okay, so now, whatever we do to the bottom, we must do to the top. So you could have done it differently to me, but I'm going to do this by 2. I'm just going to make it nice and simple. I'm going to times by 2 every time. So 24 times 2 is 48. And 20 times 2 is 40. I could have done it that way. Or I could have divided it by 2. Could have done this one divided by 2 to make another equivalent fraction. So I could have done 24 divided by 2 to make 12 and 20 divided by 2 to make 10. So these are all equal fractions, guys, because if you do the same to the top to the bottom, you've got it. Right. It now says draw lines to connect the equivalent fractions, and 1/5 and 4/20 is done for us. So it's quite interesting, is this one, guys? Let's start with a simple one. Let's look at the half. Which one here has half a numerator from the denominator? This one. So I know that that is a half, okay? So now I'm going to have a look and see if I can see any relationship between these. Well, I can see here 6 has been doubled to 3 has been doubled to 6 and 2 has been doubled to 4. So they are equivalent. I'm now going to have a look at, remember, whatever you do to the top, you do to the bottom. So if I looked at this one and I times 6 by 2 and 5 by 2, it would give me 12 and 10. So they are equivalent because I've times those by 2. Let's have a look at this one. We've got 2/9. 2/9. Well, I can see that 27 is 9 times 3, and 2 times 3 is also 6. So that works. I times those by 3, which must leave me with 11/12 is the same as 55/60. Okay, and for that one, I've done times by 5 to get those. That was a challenging one, but if you take your time, you can do it. So let's look at the bottom one. Find numbers that can make the fractions equivalent. Okay, you've got this, guys. So look at the relationship first. So you times by, dividing by 45 divided by 9 equals 5. So whatever we do, we've got to divide by 9. All right. So whatever we do to the top number, we've got to do to the bottom number. So it needs to be a multiple of 9 for us. All right. So we could do 9/45 is equal to 1/5. We could do 18/45 is equal to 2/5. We could do 27/45 is equal to 3/5. Hope that makes sense. Now we're looking at the relationship on the numerator here. So here, 6 to get to 18 would times by 3. So whatever we do at the top, we must do to our bottom. So we must do that to the denominator. So if I had 6 tenths and times it by 3, it would be 30ths. If I had 6, I'm just coming up with any number. I could have 6 quarters. Times it by 2, it'd be 18/12. If I had 6 100ths, times it by 3, it'd be 18/300. Okay? You could have done anything as long as you did the same thing to the denominator as you've done to your numerator. It can give you the right answer. Okay, guys, so that's the lesson for today. I hope you've enjoyed it. I hope you've learned some new things, and I will see you later. Well done.